All right. Today, we are kind of working our ways backwards a little bit. Normally, I give you the problem, you factored it, and you found the answers, right? Today, I'm going to give you the answers. You have to take it back to the top of the original problem. So what problem did those answers come from? That's what you're looking at, okay? So what is a polynomial function with the zeros -3, 3, and 4? So I should be able to tell my final answer should have a degree of what? 3, because I have 3 answers. So my final answer should have an x cubed in it. All right, so I wrote down your step-by-steps of things here, but let's kind of reason through this for a minute. We know that problems are always y equals, they're coming from all that kind of stuff, right? But like, if I had -3 for an answer, what parenthesis did that come from? X plus 3, right? Because normally you would set this equal to 0 and solve, moving the 3 to the other side would make it the -3. Where did +3 come from? X minus 3. And where did 4 come from? X minus 4. So it always comes from the opposite signs parentheses. Let me put those back in. So the signs just flip. Okay. So right now this is factored form. Right? It looks like it's already factored into my parentheses for me. I want you to take it back to standard form. Meaning I need to do what with all of those? I need to distribute. I just got to multiply. Okay. Now you can start multiplying any two together that you want first. It does not matter. Okay. It really doesn't. Right. If I asked you what's 2 times 3 times 4, how would you figure that out? You would do 2 times 3, which is 6 times 4 is 24. Could I go 3 times 4 first? 3 times 4 is, and then times 2. Or could I go 2 times 4, which is 8 times 3, still 24. But you wouldn't distribute the 2 to here and then distribute the 2 there, would you? That'd be weird. Don't do that over here. That's what I have students do all the time. They try to distribute, instead of multiplying like these two together first, and then taking that answer times the other one, I have people try to multiply this one by this one and this one by that one. No. That's like multiplying 2 times 3 and 2 times 4. You wouldn't do that. That's weird. Okay? So don't do that with those either. So you can pick any 2 you want to start multiplying. Me personally, I typically start with the back 2. Just because for me, whatever reason, it flows nicer. You do not have to if you don't want to. For me, it's easier. I always start with the back 2 and kind of work my way down. So just looking at those 2, let's just distribute and see what we get. X times x. X times -4. -4x. -3 times x. And -3 times -4. Positive 12. This is one of those problems, guys, as we get working. If you mess up one sign, we're in trouble. Okay, it'll mess up everything else. All right, I do have like terms. We'll go ahead and clean it up. X squared. Good. -7x plus 12. All right, so that's equivalent to me multiplying 3 times 4 and getting 12. What would I do next on this one? I multiplied those and I got 12. Then you would do what? In this example right here. You'd multiply it then by 2, right? You'd bring the 2 down and multiply those. Same idea here. I'm going to take this one that I haven't used yet. I'm going to bring it down. And now I'm going to multiply those together. Okay, so let's distribute here. So x times x squared. X times -7x. X times 12. Positive 12x. I still have to distribute the 3 through. Plus 3x squared. 3 times -7x. -21x. Multiplying 3. And then 3 times 12. 36. And then what do I do to finish it? Put my like terms together. All right, so I have an x cubed And then I have some x squared, so negative 7x squared plus 3x squared, negative 4x squared, 12x minus 21x, negative 9x, and then plus 36. Now, I don't know about you guys, but when you do that much work, that much multiplying, that many signs, how easy is it to mess up? It's very easy. I would like a way to check my answers. Would you guys like to check them? Easily, not without a lot of effort? Grab your graphing calculators. All right. So the answer we got, let's just make sure we're okay on what all this is. This is standard form. That's how I always want you to write them, in standard form, not just factored. We start factored, we have to multiply them together. And then to check these, we will actually graph this answer. To check, graph your answer. And look where it crosses the x-axis. If I did it right, where should it cross the x-axis? Yeah, it should cross at negative 3, 3, and 4. That's what the problem wanted. So go to y equals, let's go ahead and type it in, x cubed minus 4x squared minus 9x plus 36, hit graph. If you have a weird window on yours from somebody from yesterday, you can hit just zoom 6 and it'll take it back to normal. Does it cross at negative 3, 3, and 4? It does. But do you see how you can check your answer pretty quick? Literally just type it in and be like, oh yeah, there it is. Beautiful. Okay, it will do it for you, the checking. All right, so number 8, were we able to set it up? So y equals, where does negative 5 come from? X plus 5. Where does 0 come from? Ooh, very nice. Baby brother, right? Baby brother of an x gives me that. And then what about 2? X minus 2. You get 1 point just for that. That should be the easy part. All right, and then what do we have to do? We just got to multiply. Yeah. All right, again, personally, I start with the back 2. Does not matter. That's just like where I like to start. All right. So x times x, x squared, x times negative 2, 5 times x, 5 times negative 2. Please clean up like terms. You could wait and clean up everything at the end, but some of these problems, they'd be huge, okay? So clean up as you go, makes things a little easier. So negative 2x plus 5x, positive 3x minus 10. Then what? Yeah, we haven't used the x yet. We'll bring him down, and we'll multiply him through. X cubed minus 10x. You should, yes. So let's go back to our calculators. Y equals x cubed plus 3x squared minus 10x. Hit graph. Where should it cross? Negative 5, 0, and 2. It should, if you typed it all in. 1, you got to type in your answer correctly. All right, and then if you are sure you typed it in correctly and it's still not crossing where it's supposed to, it means you got a math error somewhere. So you have to go back and try multiplying it together again. But this one checks out good. All right, what about number 9? What is a polynomial function with the zeros negative 4, negative 3, 1, and 4? What degree is that one going to be? It's going to be, ooh, good vocab. It's going to be quartic, right? It's going to be x to the 4th. Is this one going to require a little more work? Yeah, it is. All right, we can do this though. So let's set it up first. Y equals, where does negative 4 come from? Where does negative 3 come from? What about 1 and 4? X minus 4. Oh. Does it matter where I start multiplying? Does not matter. You can pick wherever you want. Where is my tendency to start? The back 2. And I'm going to start there again. Starting with the back 2. X times x. X times negative 4. Negative 1 times x. Negative 1 times negative 4. Positive 4. All right, go ahead and clean up like terms. So we get x squared minus 5x plus 4. What should I bring down next? I'm going to just bring down the x plus 3 for now, just so I don't get that other one in my way. And then I'll distribute through with this one. All right, so let's try this one. So x times x squared, x times negative 5x, x times 4, positive 4x. Distribute the 3, so we get 3x squared minus 15x plus 12. Isn't this fun? It is very tedious. All right, like terms, negative 5x squared plus 3x squared is negative 2x squared. 4x minus 15x, negative 11, just x. Does not become a square because that's when we multiply. And then we have a plus 12. Am I done? No, I get to go again. So much fun. Bring down then the x plus 4. And I get to do this all over again. You guys want like 10 of these on your test, right? All right, so that gives me x to the 4th minus 2x cubed minus 11x squared plus 12x. Oh, now the 4. 4x cubed minus 8x squared minus 44x plus 48. I ran out of space. I had to come down to the next line. All right. Do we have any like terms? We better, otherwise that thing's huge. All right, so we have x to the 4th, and then negative 2x cubed plus 4x cubed. 2x cubed. Negative 11x squared minus 8x squared. Good, negative 19x squared. And then I have a 12x minus 44x. Good, negative 32x, and then plus 48. Think we should check that one? Yeah, definitely check that one, because there's a lot going on in there. All right, so let's graph it. X to the 4th plus 2x cubed minus 19x squared minus 32x plus 48. All right, and then double check. Did it cross at negative 4, negative 3, 1, and 4. If yours did not, you typed something in wrong. Ahmed was shaking his head. All right, it should, because we did all the math right down here. Now, eventually throughout this chapter, I will give you this, and you'll find all those answers for me. As of right now, do we know how to factor something with 5 terms? Nope. If I gave this to you now and asked you to solve, you'd be like, I don't know. Okay. I will teach you by the end of this chapter. I will give you this, and you'll be able to tell me all the answers. Okay. We will get to that. Aren't you excited? How are we feeling so far? Is today hard? No. I think Quinn's word was the best word I've heard used for it. It's tedious, right? And how easy is it to mess up? Very. You miss one sign, one exponent, one little bitty thing, and the whole thing's wrong. So let's give you guys a chance to practice on your own a bit. So let's practice 10 and 11, and then we'll go through them together and see how we did. All right, guys, let's go ahead and talk through, make sure we're okay with the process. So where does 0 come from? X before, right? Baby brother. What about 1? And 7? All right. Where do you want to start multiplying? Back 2. That was really loud. All right, so we should get x squared minus 7x minus 1x plus 7. Collect your like terms. So x squared minus 8x plus 7. All right, then bring down the x, and then we'll distribute here. So we get x cubed minus 8x squared plus 7x. How do you check your answer? Yeah, just graph it. And a lot of you walking around, I asked if you graphed it, and you're like, nope. Don't be that lazy, guys. It's not that hard. Type in some buttons, okay? So make sure you're checking them. Right, so I'm not making you graph it by hand to check it. We still want to make sure we're accurate lazy mathematicians. All right, and then number 11, where does negative 2 come from? 0, x out in front, 3, 5. All right, what form is that? What's that called? That is standard form, or no, that's not standard. I want standard. That's factored form. Factored has the parentheses in it. All right, starting with the back 2, we get x squared minus 5x minus 3x plus 15. At least you're finding out it's a sign problem, right? So then x squared minus 8x plus 15. Yeah, you miss one sign, the entire thing falls apart. Oh. All right, and then from here, we'll have x cubed minus 8x squared plus 15x plus 2x squared minus 16x plus 30. Like terms, we have x cubed. That's going to give me negative 6x squared minus x plus 30. And we're going to bring down the last x. And your hand hurts by this point because you're tired of writing. We're almost done. X to the 4th minus 6x cubed minus x squared plus 30x. Don't forget your y equals. Whew, and we are done. Did anybody get both of them right? Good. Back row and one in the front of the room. Okay. First time. I guess, where is the problem coming. I think Angel said she added instead of multiplied, right, on those one numbers. Multiplied instead of minus. Okay. So it's basic math that's coming to bite us in the butt, right? Oh, 5, 3. Clearly 7. Yeah. It's always the basic math. It's never the algebra that what messes people up. Like the ongoing joke is always basic math is hard, right? That's where we make the simple mistakes. All right, but can you check all these? Yes, please check them. Don't get that lazy that you can't just type it in to check it. Okay, so it's a 4-point problem on a test. Do you want -4 or spend a few more minutes and get it right? Ben? Well, sometimes you show your work, so you should be able to kind of see where things start to go bad, right? Okay, question. If you're going back to check this problem's huge. You're like, I don't want to start that over again. Could you, yeah, don't get it wrong. But let's say you graphed this at the bottom and it didn't work, right? I get it. You don't want to retype, you don't want to redo the entire thing. Okay, could I come back to one line before it and type this in my calculator? Yeah. And if that works, then you know that something went wrong between here and here. If that still doesn't cross where it's supposed to, go one line above that. Type in all of those crazy like terms that you just put together. Type that whole thing in. If that works, great. Then you know the problem went from there to there. Okay, if you can find the line where it works, it doesn't work, you know you messed up somewhere. It graphs and goes through those points. Yep. So you could graph each line as you go even, if you really want to. If you're like, I'm not sure I put that together right, graph that line, right? If you're like, that's a lot of like terms, graph that. Make sure it works before you even put them together. Put them together and be like, okay, let's graph that again, make sure I got it all. Now, granted, when you're graphing each line, do you still need the other parts you haven't multiplied yet? Yeah, you still need those. Okay. You still have to have all the other parts and pieces with it. All right, questions on how all this works? We're okay?